Do you like pink? Then this video is for you. But there will be no pink ponies, pink handbags, or pink mini pigs here. Instead, we're going to talk about the pink side of Antarctica. Yeah, this icy continent is not always white. In some places, it turns pink for very strange reasons. Let's take a tour of the pinkest places in Antarctica and uncover their secrets. Antarctica is home to many high mountains and volcanoes that hide all kinds of mysteries. One of them is pink rock. In West Antarctica, among the peaks of the Hudson Mountains, large boulders covered in a pink pigment lie scattered across the landscape. They've puzzled scientists for decades. These stones are made of granite. The pinkish hue of this rock is given by a mineral called feldspar. Pink granite can be found in many places around the world. But why are these rocks sitting among high mountains? Logically, you might assume they broke off from nearby peaks. But the problem is that the mountains themselves have no pink shade at all, which means someone or something removed these rocks from a large granite body and brought them here. But then, where is that massive block of granite? Well, scientists asked themselves the same question and launched a large-scale investigation. First, they analyzed the pink rocks and discovered that they formed about 175 million years ago, during the Jurassic period, when tyrannosaurs were walking the Earth. Hey, I wasn't around then. Well, what if some big, strong dinosaur simply dragged them here because it liked the color? It's a funny theory, but there has to be something else. Scientists decided to fly over the Hudson Mountains in a research aircraft equipped with unique geological sensors. Using special instruments and aerial surveys, they carried out precise gravity measurements and detected a geological signal beneath the Pine Island Glacier. The signal came from a massive granite body roughly half the size of Wales. Okay, now we know where the rocks came from. But how did it happen that gigantic granite deposits ended up beneath a glacier while these stones were scattered across mountain peaks? Well, tens of thousands of years ago, during the last ice age, the glacier in this region was much thicker than it is today. Millions of tons of solid ice pressed down on the granite below. The pressure was so intense that large chunks broke off from the massive pink rock and were pushed high into the mountains. But wait a minute, how is that even possible? A giant glacier presses down on a giant block of granite and somehow squeezes rocks out into mountain peaks? Well, first of all, a glacier is frozen water. In some places, it can melt and seep into cracks in the rock. When it freezes again, it expands and splits the rock apart. Second, glaciers move very slowly over tens and hundreds of thousands of years. A glacier grinds across the granite with its enormous weight, breaking it apart and pushing the smaller fragments along. And those small pink pieces are exactly what scientists found. It's like sandpaper moving across the surface of a wooden beam and scattering shavings in different directions. But why does this matter? Scientists can now better understand how glaciers move and change, and how they interact with the rock beneath them. Most importantly, they can see how Antarctica is changing as global temperatures rise. This helps us predict future climate changes on our planet. Now, let's come down from the high mountains and walk across the crunching snow. The white surface reflects sunlight and blinds you. You search for a darker spot to give your eyes a break, and suddenly you notice a large pink patch. It looks as if someone ate a watermelon here and spilled all the juice onto the snow. This phenomenon is called watermelon snow, but it has nothing to do with the fruit. The unique color is caused by a special type of algae called this. Hey, you try to pronounce this. Right now, these algae appear pink or red because they are in a dormant state. During their reproductive stage, they turn green. When you walk through a park and see yellow and brown leaves, you know it's autumn and the trees are preparing for winter. In Antarctica, instead of yellow leaves, there are pink algae. They turn red as they prepare for the long cold winter, and turn green again as the seasons change. But why do they do this? Well, the change in color helps them survive. White snow reflects sunlight and heat, but pink or green shades reduce reflectivity. The surface absorbs more heat, causing the snow to melt, and the more snow melts, the more water the algae receive. But are water and sunlight really enough for algae to live? Well, of course not. They also need nutrients. But how do they get them? The continent's residents provide the nutrients, and these residents are penguins. These adorable animals go to the bathroom, and their droppings fertilize the snow. Even a tiny amount of dust from penguin poo is enough to supply the algae with the nutrients they need. Now, scientists believe that in the future, pink snow will become much more widespread across Antarctica as temperatures continue to rise. So, if you ever find yourself on this continent with friends and spot pink snow, you can show off your knowledge and explain the science behind it. However, if someone feels tempted to taste the watermelon snow, don't let them. The snow may look like fruit sorbet, but the algae in it are toxic. And don't forget, it also contains particles of penguin doo-doo. So, pink rocks have a pale shade. Watermelon snow has a brighter pink. The colors are getting more intense. And our next phenomenon is hard even to call pink. It has a dark red tone and looks a little eerie. Just look at this. Red water pours out of a glacier, staining everything around it with an ominous color. It's been flowing here for hundreds and possibly even thousands of years. When researchers first noticed this waterfall in the early 20th century, they were shocked. For a long time, no one understood the nature of this phenomenon. People speculated why red water was flowing out of the glacier and what gave it that color. Was it even water? The imagination runs wild. But relax, it really is water. And it isn't actually red. It's transparent, just like the water that flows from our taps. It simply contains something special that changes color upon contact with oxygen and sunlight. Now think about what happens to iron when it gets wet. It oxidizes, forms rust, and turns reddish-brown. Roughly the same process happens here. The water inside the glacier contains a huge amount of iron. When it flows out and comes into contact with oxygen, it oxidizes and takes on this eerie color. This explanation seemed perfect, and scientists were confident in it until they discovered something more. They studied samples of the water and found iron-rich nanospheres. Now, nanospheres are tiny particles, about 100 times smaller than a human red blood cell. In addition to iron, the nanospheres from the waterfall also contain calcium, silicon, aluminum, and sodium. When these nanospheres come into contact with oxygen, they turn red. But where do these nanospheres come from? And why don't we find anything like this in the bottled water we drink? Well, this Antarctic water has been trapped inside the glacier for hundreds of thousands, maybe even millions of years. In a way, it exists outside our planet's atmosphere in unique conditions. There's no light, no air, and everything is cold. Who knows what kinds of microorganisms live there and how they affect the water? Many things could be producing nanospheres and enriching the water with them. Scientists studied this waterfall not only to solve its mystery. They believe that if life can exist under such extreme conditions in Antarctica, it might also exist in similar environments on other planets. There are cold, sealed caves without sunlight and oxygen on Mars. What if microorganisms live there too? By studying the phenomena like this on Earth, we can better prepare for future research missions to Mars.
Leave it to people wandering on Google Earth to stumble upon the world's newest and weirdest places ever. Like this mysterious pyramid discovered in Antarctica. Soon enough, the internet blew up with all sorts of theories regarding this unusual shape. Could it be a sign from a different life form? Is this pyramid indeed natural, or is it man-made? For starters, it's not the first time we've discovered a pyramid in the Antarctic. The first one was observed by the British Antarctic expedition in the 1910s and kept secret for a long time. Its discovery being kept hidden only added to the mystery. A second such structure was discovered in 2016, which further increased the interest in the matter. The mystery was soon enough deciphered by scientists. These formations are just mountains. They're located near the Ellsworth Mountains, a range over 250 miles long, so they're just mountain peaks that have broken through the ice sheet. As for their particular shape, it's just a coincidence. Pyramids are found throughout nature. The Matterhorn in the Alps and Mount Ballenstinder in Iceland, for example, are quite similar in terms of shape. As for the official name of these peaks, they're called nunataks, or peaks of rock peeking through a glacier or an ice sheet. Antarctica has way more incredible features, like the fact that it's home of 60 to 90% of the world's fresh water. That's because its ice sheet is the biggest on our planet, stretching across 5.4 million square miles. I'll spare you the calculations, but that leaves only 1% of the continent ice-free. Antarctica's ice reaches 2.7 miles thick at its deepest point, meaning half the height of Mount Everest. Should it ever melt completely, our sea levels would rise to roughly 200 feet. It wasn't always this cold, though. At some point in our planet's history, Antarctica had some average temperatures as the city of Melbourne has today. It took a lot of research, but scientists figured out that Antarctica's temperatures could have reached up to 62.6 degrees Fahrenheit. Sure, that was 40 to 50 million years ago, but if you think about it, it was at the same time when dinosaurs roamed our Earth. Time is also different on this icy continent. All the lines of longitude that help us calculate different time zones merge into a single point at the South Pole. Here, there are 6 months of daylight in the summer, followed by 6 months of complete darkness during the colder season. So, scientists working here stay, on average, in the same time zone they've come from. The Blood Falls aren't a chapter of a thriller movie. They are merely a series of waterfalls located in one of the driest regions of Antarctica. They emerge from an underground lake filled with a special type of bacteria. These little organisms use sulfates as fuel instead of sugars, which makes them very intriguing for scientists. The water contained in this lake is so full of iron that it basically just rusts when it meets air. So, the reddish color of the waterfall also gives it its trademark name. The megalodon was the largest predator ever known in our planet's history. In terms of its location, the megalodon lived practically in all waters on our globe, except near the poles. The reason why there were no megalodon teeth found in Antarctica is probably because the gigantic creature was adapted to only warm tropical and subtropical waters. If you plan to visit Antarctica by boat someday, just know you might not get there on a non-metallic boat. The hull of your transportation device must be made of either steel or aluminum to withstand the harsh weather conditions here. Antarctica isn't home to a lot of bugs. In fact, there is only one true species of insect that calls this place home. It's a wingless midge called Belgica antarctica. This fly is so tiny that it only reaches 0.08 to 0.23 inches long, but it's still the Antarctic's largest terrestrial animal. A lot of Antarctic fish also come with an antifreeze substance in their blood. They don't necessarily need it for protection against the cold temperature, but mostly against touching ice. These antifreezes are made up of large glycoprotein molecules. They surround any small ice crystals that may form, making sure they don't spread through the animal's tissues, which could cause a lot of damage. They also create a sort of small pillow blocking the sharp ice crystals, so they're less likely to cause any pain. It also doesn't rain a lot here on this icy continent, but one amazing meteorological quirk of Antarctica is that it's full of diamond dust. This dust is basically small ice crystals that pop out of humid air close to the Earth's surface. Think of it like an icy fog. As they flow through the air and get touched by sunlight, they begin to sparkle, making visitors here feel like they're surrounded by diamonds. It's probably the last place you'd want to go into labor, but in 1978, the first person was born here ever. Emil Marco Palma was its name, and ever since, 10 other people have been born here in Antarctica. There's a lake on this icy continent that is so full of salt, it makes it impossible for it to freeze over, even if temperatures can go as low as 5 degrees Fahrenheit. That's because pure water freezes at 32 degrees Fahrenheit. Water that has salt in it, or any other substance for that matter, will freeze, but at a way lower temperature. That lower temperature is adjustable depending on the substance itself and the amount that has been placed into the water. Antarctica was the last official continent to be discovered. It remained completely unseen until the 1820s. But it took another 20 years to confirm it was actually a continent and not just a group of icy islands. Just because it's really cold here doesn't mean you can't go on a date here. One December night, an American scientist that was posted in Antarctica logged into a dating app simply out of curiosity. He was certain no other profiles would show up, but to his surprise, he found someone soon enough. Another researcher who was stationed just 45 minutes away, by helicopter of course. They eventually got together and went on the first date in Antarctica ever recorded. Apart from ice, this continent has something else way more abundantly than any other piece of land on Earth: meteorites. If we look at the research done by scientists, meteorites have equal chances of reaching any place on our planet. However, once they go through our atmosphere, the situation is a bit more complex. That's because different climates on our planet, like the humid ones found near the jungle, have a lot of moisture and oxygen, which will corrode most meteorites. The climate in Antarctica is really dry, so the possibility of meteorites corroding is little to none. More so, it's way easier to spot these rocks on the icy white surface of this area than in any other place on Earth. If you're not scared of the cold, you'll surely freak out when you hear about the winds here. That's because Antarctica is for the most part the windiest place on Earth. Wind speeds have been reported here to reach even 200 miles per hour. Antarctica, a snowy world of about minus 46 degrees Fahrenheit, covered in ice for millions of years. But it wasn't always this way. Scientists just found something buried deep beneath the seafloor that shouldn't exist. Tiny golden droplets of amber. This means that Antarctica was once teeming with life and thick with trees. But something happened to it. Something that could reshape the way we see our own future. Antarctica has been a land of howling winds for millions of years. No tree can grow here today. But scientists who studied those lands decided to drill deep beneath the Antarctic surface. They went thousands of feet below the ice, pulling up ancient layers of sediment. And there, trapped in time, they found tiny pieces of golden amber. Amber is basically fossilized tree resin. It's found all over the world, often with perfectly preserved pieces of ancient life. Insects trapped mid-flight, pollen frozen in time. Entire tiny ecosystems can be locked inside golden droplets. In every continent, but not in Antarctica. Until now. They discovered tiny specks from 0.5 to 1 millimeter in size, smaller than a grain of sand, but with huge significance. This droplet had once oozed from the bark of a tree about 90 million years ago. What's even wilder, amber is only produced by certain types of trees, the ones that grow in humid, temperate rainforests and jungles. That's when the realization hit. Antarctica used to be a rainforest. Those tiny flecks of amber, clearly seen only under a microscope, tell us a vivid story of a living and breathing ecosystem. Around 90 million years ago, during the Cretaceous period, when dinosaurs ruled the Earth, Antarctica could have been covered in lush, swampy forests filled with towering conifers, ferns, and ancient plants. Some of the fragments showed signs of damage. That means the trees that produced them had been injured, perhaps by wildfires or parasites. Though despite that, and despite the fact it spent millions of years on the seafloor, this amber was almost perfectly preserved. Solid, transparent, and free of cracks. Normally, amber buried under extreme pressure and heat just crashes over time. But this piece, it survived. That means other pieces could survive as well, and we might find more of them on the ocean floor. But this wasn't the first sign that Antarctica had once been a different place entirely. It started in 2017. A team of scientists drilled deep into the seabed near Pine Island Glacier on Antarctica's west coast. They pulled up sediment cores, long cylindrical samples of Earth that had been buried for millions of years. And it was insane. Inside these layers, they found fossilized roots, pollen, spores, traces of an ancient forest that had once thrived here. And that's exactly what they'd been studying ever since then. In order not to damage anything, they had to spend years of hard work, breaking down the sediment into thousands of tiny pieces and scanning them all under fluorescent microscopes. The same team also found another piece of the puzzle back in 2020. They found more sedimentary samples from the ocean floor that pointed to a land of dense trees, rivers, and wetlands. A world that looked more like the Pacific Northwest or New Zealand. But why was Antarctica so warm back then? Well, that's all because of the atmosphere. 90 million years ago, Earth's carbon dioxide levels were terrifyingly high. It was literally one of the warmest periods in history, with temperatures soaring even at the poles. Think about it. Antarctica had no ice caps. Instead, it could have had buzzing insects and maybe even dinosaurs wandering through its forests. But in order to learn what happened to them, the team has to find more evidence. Antarctica really is a place full of mysteries. It's hard to study because it's covered in snow and ice so much that we don't even know its true shape and size. Some parts of the ice sheet are over 3 miles thick, half the depth of the Mariana Trench, the deepest trench on Earth. Luckily, snow has a great quality. It can freeze things in time perfectly. Layer by layer, year after year, it buries nature's past like a time capsule. Luckily, snow has a great quality. It can freeze things in time perfectly. Layer by layer, year after year, it buries nature's past like a time capsule. At first, fresh snow is soft and shifts easily in the wind, full of air. But as more snow piles on top, it compresses, squeezing out the air pockets and hardening into dense ice. This freezing pressure locks everything inside. It traps ancient plants, animals, and even entire landscapes. And they literally get frozen in time, because the extreme cold slows down decay. It stops bacteria growth, preventing rot, and keeping things almost perfectly intact for thousands, sometimes even millions of years. That's exactly what's going on in Antarctica. Scientists have to literally scan it all the way down this snow in order to find what this place looked like millions of years ago. What they found is an entire lost world buried under miles of ice. It was beneath the thickest ice of East Antarctica, near the Aurora and Schmidt subglacial basins. The weight of the ice has been so immense for so long that it actually protected the land from erosion. Scientists call it the ghost of Antarctica's landscape, and it's nothing like the smooth, flat wasteland seen from above. They found rivers that once flowed freely, now frozen in place, valleys carved by water, even 3 massive, sharply peaked hills. But what are they? To understand that, we need to go even further back in time, to the era when Antarctica was still part of a lost supercontinent. Hundreds of millions of years ago, the land we now call Antarctica was part of Gondwana, an enormous supercontinent that included South America, Africa, India, Australia, and Antarctica all fused together. But as Earth's tectonic plates slowly drifted apart, Gondwana broke into pieces. Antarctica was ripped apart, its land stretched and fractured. The massive ice sheets that formed later covered these broken landmasses, preserving them like frozen fossils. As the ice shifted and melted over time, valleys formed, and ancient rivers likely carried water toward a coast that was hundreds of miles away from where it is now. But that's not the only thing Antarctica has hidden. If you stripped away the ice, you wouldn't see a smooth, empty continent. You'd see a super dramatic landscape, towering mountains, deep valleys, even fiery volcanoes. In West Antarctica, at least 138 volcanoes are buried under the ice. One of them, Mount Erebus, is still active. And inside, it has warm volcanic caves where you could walk in a t-shirt. Oh, and if it wasn't weird enough, Erebus is also spewing out gold. Yep, the actual tiny specks of gold from deep within the Earth. Scientists believe this happens because magma, the superheated semi-molten rock beneath the Earth's surface, carries liquid gold with it as it rises. Every single day, Erebus releases about 0.2 pounds of it. That's worth around $6,000 per day. In a year, that adds up to 64 pounds, or more than $2 million, floating into the sky. Unfortunately, before we grab shovels, we gotta remember that those are just microscopic particles. They're often smaller than 60 micrometers, thinner than a human hair. Not even mentioning that they're scattered around up to 620 miles away from the volcano itself. Finding them is nearly impossible. But that just shows that even in such a harsh place that looks just like a white desert, there are still many fascinating mysteries to discover. For example, somehow, life still clings there. In 2017, scientists drilled deep beneath the ice of the Ross Ice Shelf looking for water. But they found something fantastic instead. A river hidden beneath 1,640 feet of ice, running through the dark. And inside it, hundreds of tiny shrimp-like creatures. They swarmed around the camera, blocking the lens, welcoming the scientists. In deep caves beneath the ice, DNA evidence has also shown traces of moss, algae, and possibly even unknown tiny animals. So, turns out, even in one of the harshest places on Earth, life finds a way. And who knows what else we'll discover in the South Pole? A vast expanse of white snow, freezing winds, lifeless landscapes, and weird, eerie signals seemingly coming from within Earth. These radio pulses occur in Antarctica, and no one can figure out what they are and where they're coming from. You see, scientists are running an experiment called ANITA, short for Antarctica Impulsive Transient Antenna. Basically, it's a bunch of detectors strapped to giant balloons and floating way up above the South Pole. Their job is to detect extremely high-energy neutrinos. How do they spot them? Right at the moment when neutrinos come into contact with ice and produce an intense, short burst of radio waves. Now, neutrinos are these tiny, almost massless particles that don't have an electric charge. They're everywhere, and billions of them are flying through you every second, even while you're watching this video. Neutrinos come from all over the place, from the sun, exploding stars, deep space, even from under your feet. The sun pumps them out non-stop as it fuses hydrogen into helium. Stars that are going off blast out huge bursts of neutrinos during supernova explosions. When high-energy cosmic rays hit our atmosphere, they make new neutrinos that rain down on us too. And some even come from radioactive stuff decaying inside Earth. The oldest neutrinos have been flying through the universe since the Big Bang, but they're practically invisible because they almost never react with anything. That's why scientists use unbelievable experiments like ANITA to try and catch even a few of them. But let's get back to that fateful day when everything changed. Normally, the radio signals produced by neutrinos bounce off the ice and fly upward. That's where ANITA can catch them. This is the whole point of the experiment, to study neutrinos and learn more about distant cosmic events like supernovas or whatever's happening light years away. But then something really weird happened. The detectors picked up radio waves that weren't bouncing off the ice at all. They looked like they were coming from below the horizon, from under the ice. Now, this shouldn't even be possible. According to everything we know about physics, signals can't just travel upward through solid rock and ice. One of the researchers, Stephanie Wiesel from Penn State, also said that those radio waves were coming in at super steep angles, like 30 degrees below the surface. The only way that could happen is if the signal had passed through thousands of miles of solid rock before hitting the detector. But if that were true, the rock would have completely absorbed it. So something just didn't add up. The team ran all the numbers and still got no clear answer. But for them, it was an interesting problem, since they didn't actually know what those anomalies were. What they did know was that they were probably not neutrinos.
That's because if the team does detect a neutrino, that means it's traveled an insane distance without bumping into anything, possibly all the way from the edge of the observable universe. So, whatever Anita has picked up, it's not behaving like anything scientists have seen before. It might mean there's some totally new type of particle out there, or maybe something else is going on that we just don't understand yet. They publish the findings in physical review letters, but the mystery remains unsolved. No one really knows what's going on under that Antarctic ice, just that something out there isn't playing by the rules. Now, if scientists actually manage to detect and trace where those crazy fast particles come from, they can learn tons of stuff about the universe. Way more than even the biggest, most expensive telescopes allow us to see. You see, neutrinos basically zip through space almost at the speed of light, barely bumping into anything. It means they can carry untouched data about events that happened millions or even billions of light years away. That's why Wiesel and a bunch of other researchers around the world have been building these insanely sensitive detectors to catch neutrino signals. Even the tiniest ones are super important, because in this field, one tiny blip of data can hold a treasure chest of information. So, researchers have been designing setups in both Antarctica and South America to catch these rare particles. Anita is one of those detectors, and Antarctica's the perfect spot for it. There's hardly any radio noise, there are no cities, no traffic, and no random interference. The setup is actually pretty cool. They attach a cluster of radio antennas to a giant balloon, send it a few dozen miles up into the sky, and make it float over the endless stretches of white ice. From up there, it points downward, listening for faint radio signals coming from deep inside the ice. When one of those super rare neutrinos, specifically a tau neutrino, hits the ice, it creates another particle called a tau lepton. That lepton then shoots out of the ice and starts breaking down, losing energy and turning into smaller bits. That decay process gives off what's called an air shower, kind of like a spray of invisible sparks flying through the air. If we could actually see those air showers with our eyes, they'd look like someone waving a sparkler through the dark, bright streaks trailing behind as it moves. Studying the direction and pattern of these signals, the ones from the ice showers, and the ones in the air showers, scientists can figure out where the original particle came from. Usually it's super precise, kind of like bouncing a ball off the ground. You can predict where it'll go. But these weird new signals don't bounce the way they're supposed to. The angles are all wrong way steeper than anything the models can explain. So the team dug deeper. First, they looked at all the data from Anita's multiple balloon flights. Then they compared it against tons of computer simulations of cosmic rays and neutrinos and filtered out all the usual background noise. They even cross-checked their results with other experiments like the ice cube detector, which is also located in Antarctica, and the Pierre Auger Observatory in Argentina. They wanted to see if anyone else had picked up similar upward-going air showers. And guess what? Things got even weirder. They found nothing. No other detectors had picked up anything that could explain what Anita had seen. That's why the researchers ended up calling the whole situation anomalous. It basically means, yeah, we have no idea what this is, but it sure isn't behaving like a neutrino. Wiesel explained that the signals just didn't fit into the usual picture of how particles were supposed to act. Some people have floated ideas, like maybe it's some new kind of physics, or a hint of dark matter. Dark matter is basically that invisible stuff that keeps the universe from falling apart. It's everywhere. We just can't see it. Scientists have been trying to figure out what it actually is for almost a century, and it's still one of the biggest mysteries out there. Everything we can see, like stars, planets, people, dogs, makes up only about 5% of the universe, and dark matter makes up around 27%. The rest is something even stranger called dark energy. Scientists think dark matter is what gives galaxies their shape and holds everything together like cosmic glue. Without it, the universe would look totally different. It would be totally amazing to find out that this theory is true. But since Ice Cube and Auger haven't caught the same thing, that really limits the possibilities. Penn State has been in the neutrino detecting game for almost a decade now, building detectors and analyzing all kinds of cosmic signals. And the team is already working on their next big project, a brand new detector called Puel. It's going to be bigger, more sensitive, and way better at spotting those elusive neutrino signals. For now, this remains just one of those long-running cosmic mysteries that keep scientists awake at night. But the team is optimistic. When Pueo goes up, it'll have better sensors, which means if there really are more of these anomalies out there, this time they'll catch them. And maybe then we'll finally figure out what's behind them.